Hi everyone, and welcome back to Educator.com. I'm Dan Fullerton, and in today's mini lesson we're going to go through the first page of the A+ Physics worksheet on Newton's first law, and you can find the link to download that down below the video here. So let's dive right in. Number 1. As shown in the diagram, an open box and its contents have a combined mass of 5 kilograms. A horizontal force of 15 newtons is required to push the box at a constant speed. Anytime I see that, right away I think acceleration equals 0, of 1.5 meters per second across a level surface. The inertia of the box and its contents increases if there is an increase in the, well, if we want its inertia to increase, well, inertia and mass, almost synonymous. Mass is a measure of an object's inertia, so what we're looking for is an increase in mass. Correct answer there must be 2. We'll get an increase of inertia if we have an increase in the mass of the contents of the box. Number 2, which unit is equivalent to a Newton per kilogram? Well, a Newton per kilogram. Here's how I would do a problem like this. I don't know what that's equal to, but I know newtons measure force, and force is equal to mass times acceleration. So I'm going to say that Newton is equal to the units of mass times the units of acceleration. So a Newton must be equal to the units of mass, a kilogram, and acceleration, a meter per second squared. So a Newton per kilogram would be a kilogram meter per second squared, and I've got to divide the kilogram. Kilograms will make a ratio of 1, and I'm left with a meter per second squared. Answer 1. Number 3, which of these objects has the most inertia? And again, inertia, mass, same thing. So in this case, the one with the most mass is number 4, a 10 kilogram sled at rest. Number 4, if the sum of all the forces acting on a moving object is 0, that means the net force is 0, the object will, well, Newton's first law, if there is no net force on an object, it's going to continue at a constant velocity. So answer 4. It's going to keep doing what it's doing. Number 5, the mass of a high school football player is approximately, well, mass is a measure of an object's inertia, but the mass of a high school football player, more of an idea if you can estimate metric units. That's going to be about 100 kilograms, on the order of 200 and a little bit more pounds, for those who are more familiar with pounds. About 100 kilograms is a pretty big solid person. Number 6, which object has the greatest inertia? Again, if you don't like the word inertia, write mass in there. Answer 4. Only one that has the most mass, 20 kilograms. All of this stuff about how fast they're moving doesn't make a difference. Number 7, we've got a data table that lists the mass and speed of 4 different objects. Which object has the greatest inertia? Well, same deal. Again, we're looking for the one that has the greatest mass. There it is, must be object D. Correct answer 4. Number 8, a half kilogram cart is rolling at a speed of 0.4 meter per second. If the speed of the cart is doubled, the inertia of the cart will, well, again, what's going to happen to the cart's mass if you double the speed? Nothing. It's going to remain unchanged. Number 9, which person has the greatest inertia? Again, if you don't like the word inertia, write mass in there. And by far the biggest mass is going to be the 110 kilogram wrestler. That's a solid wrestler. And finally, number 10 here. Which object has the greatest inertia? A falling leaf, a softball, a high school student, or a helium-filled toy balloon? Well, again, if you don't like the word inertia, think of mass. By far the most mass out of those choices is the seated high school student. Has a mass of around, 60, 70 kilograms, probably a typical high school student. All right, that concludes page 1 of our worksheet on Newton's first law. Thanks so much for your time, and make it a great day, everyone.